Sorry, class, we're waiting on Jacob. All my internet fans. All right. Of course, it's a triangle. X plus 2, 5x minus 3, and 4x plus 1. What do you know about every single triangle that has a right angle in it? You know Pythagoras. There's A, there's B, there's C. So, x plus 2 squared plus 5x minus 3 squared equals 4x plus 1 squared. Then you do the math. X squared plus 4x plus 4 plus 25x squared minus 30x plus 9 equals 16x squared plus 8x plus 1. Now what do you do? Gather your like terms. X squared's first. There. 26, and I'm bringing 16 over, so that is 10x squareds. They're gone. Then my x's. 4 minus 30 is negative 26, minus 8 more is negative 34. Right? Minus 34x. And then my numbers. 4 plus 9 is 13 minus 1 is plus 12 equals 0. Now, what do I do with that?
Would you bring out the factor?
Of course you would factor that. What would you bring out? 2. What I was looking for, Ashton, there, what do I do with that is factor, right? You do all the factoring you can. So the first one is 2. 5x squared minus 17x plus 6. Now, if I'm factoring, do I need this 2 at the front? If I'm factoring only, do I need that 2? Okay. If this equals 0 isn't there, do I need that 2 at the front? Yes. But since that 0 is there, do I need that 2 at the front? No, because I am just trying to find x, right? Now, solve that. Factor it first. I need to multiply to what? 30. And add to what?
Negative 7.
What is it?
Negative 2 or negative 15.
X, not plus, idiot. X minus 2 over 5 and x minus 15 over 5. What do I do to any fractions that I see? Simplify. That becomes negative 3. Now, what are my possible values for x? 3 and 2 over 5, correct? Everyone agrees? Everyone should have gotten to there easily. One of those is the right answer. One of those is the wrong answer. Which is wrong?
3.
You got a fitty shot. We got 1 vote for 3 is saying right or wrong. Ashton, I just said 1 is right, 1 is wrong, and you said 3. The 3 is wrong, so we've got 1 vote for 3 being wrong. 2 votes for 3 being wrong. 3 votes for 3 being wrong. 4 votes for 3 being wrong. All right. In math, in English, what does that sentence say? What's highlighted there? If you were to read me that in English, what would you say? X is 3 or 2/5, yes? What letter do you see right there? So what is x? 3 or 2/5. So 5 times 3 minus 3 is what? 12. 5 times 2/5 minus 3 is what? Negative 1. Can a distance be negative? Yes or no? No, of course not. So what's really the wrong answer? Yeah, I'd like to change my vote too. That's wrong. X has to be 3. Now, please notice, have we come across math where we have gotten false answers? Yes, we have, haven't we? It's okay, buddy. Relax. It's okay, man. No, Ashton, don't hang your head, man. You're cool. It's okay. It's cool. It's cool. All right. Please turn the page over to 79. Solving these 6 equations, solving these 6 equations while I negotiate with you, causing the solving these 6 equations should take about 5 seconds each. Why? What is the hint about this? It's a perfect square. So this factors, I would need numbers that multiplied to 25 and added to 10. What are they?
5.
It's going to be x plus 5 squared equals 0, yes? Okay, so now you should be able to do all the rest of these in about 2 seconds each. What's this one? X plus 3 squared. What's this one?
7.
X plus 7 squared. What's this one?
X minus
X minus 4 squared. What's this one? Squared. What's this one?
X minus 10 squared.
All right, everybody cool? Now, read what this says. What do you notice? Talk to me. What do you notice? Why? What is the pattern that you see?
The second is the number multiplied by itself, and the first one's the one added together.
Nobody can see a pattern here. Even though you were all able to do 2, 3, 4, 5, 6, once you saw 1, you're going to tell me you can't see a pattern here. What is the pattern? Maybe this will help. That's A, that's B, that's C. Does that help? B divided by 2. So squared equals what? C. Everybody sees that? The B term, no matter what it is, if we cut it in half and square it, we get C, yes? So anytime you see a perfect square trinomial, which is the middle term divided by 2 squared is the third term, you automatically know how to factor it, yes? So what if I gave you this? Could you tell me the answer to that? Of course, it is x plus 14 squared equals 0, yes? Which means x plus 14 equals 0. What is the answer to that? How big is x? X will equal negative 14. Does everybody understand? No matter what I write here, if this number cut in half and squared gives me that number, I automatically can factor it. Yes? Everybody agrees? No matter what, right? Right? So what if I gave you this? Y squared plus 10y plus 25. Does that work? Okay, what if I gave you m squared plus 3m plus 2.25? What's half of 3? What's 1.5 times 1.5? Does it work? Excellent. Everybody cool? as long as I can split that and square it to get that, I know how to do this, right? Now remember, we already have one version of solving these, don't we? We just did 2 whole pages of it. If I gave you x squared plus 8x plus 6, could you solve that? It's not a perfect square, is it? No, but we would be able to solve it, right? What allows us to solve this? What concept allows us to solve this? No, single concept. You just did 2 pages of it. Factoring. Because that is x plus 4. Sorry, that one doesn't work. I needed it to be this. X plus 4, x plus 2 equals 0, and x equals -4 or -2, right? If we can factor it, we can solve it. If it's a perfect square, we can solve it, yes? So let me ask you this. X squared plus 7x plus 3. Sorry, let's make that -3. And let's make that 8. Now, let's look at that closely. Is it a perfect square trinomial? No, of course not. Right? Okay. Is it factorable? No, of course not, because there are no factors of 3 that add to 8, are there? But if we could change it to make it look like something that is factorable or a perfect square, could we then do it? Have we done lots of math that changes the expression to something we can work with? We've done a ton of it. It's just algebra, yes? If I change one side and I change the other side by the same amount, do I still have the same thing? Just like rationalizing the denominator, just like solving for x, we have some tools here, don't we? So please notice this is called completing the square, right? So this is what we are starting with. X squared plus 8x minus 3 equals 0. And we are in trouble here because, 1, it's not factorable in any way, is it? So we're kind of screwed, right? But let's have a look at this situation. Can I move this over here? I can, can't I? So that gives me x squared plus 8x, and leave a space here, equals what? 3. Everybody cool? All right. This will factor now, won't it? Won't it? It'll factor, right? Yeah? Okay. We could take x out, yeah? Everybody's cool? All right. But I gotta keep that in your head. What is this called? Completing the square, right? What did we just learn about? Perfect square trinomials, right? Okay. So how could I take this and complete a square trinomial? What would I have to do? Mateus? Divide 8 by 2 to get what? And then do what? Square it, which is what? Now, how much did I add to the left side of the equation? This is not a trick question. I added 16. What do I have to do to the right side of the equation? I have to add 16, right? Now what do I have? X squared plus 8x plus 16 equals 19, yes? Does everyone agree? Okay. Now we bring math to the party. What can I do with that? I don't know what to do, Mr. Myers. You're right, I haven't taught you. But you do know what to do when you see a trinomial. What is it? Factor it. Is that now a perfect square trinomial? Have we completed a square? Okay, well, what is that? X plus 4 squared equals what? All right, now what's our goal when we have x equaling anything? What? To find out what x is. Our job is to isolate it, yes? What is in the way of x being isolated right now? The fact that it is squared, yes? What do I do to get rid of squared? I square root, the opposite of what I see. If I square root the right-hand side, the left-hand side, what must I do to the right-hand side? I must square root. Now, here is something weird is going to happen. Last unit, when we did radical equations, once we squared something, we opened up the possibility of extraneous roots, didn't we? And we just did a question with an extraneous root, didn't we? So are extraneous roots still part of our possibilities? Maybe. And we know we're graphing parabolas, aren't we? So I need 2 x values for a lot of parabolas, don't I? So I'm going to need 2 answers here, yes? Okay. What happens to, for example, 25 when I square root it? Last unit, what is the answer? Because we only were seeking the positive one, right? But isn't there another answer? What is it? -5. So the square root of 25 is really plus or minus 5, right? So when I square root 19, what do I actually get? I get x plus 4 equals what? Plus or minus what? Root 19. Now, is x almost isolated? What am I going to do to isolate x? -4 plus or minus root 19. Now, you're smart kids. We're going to use estimating here because this is done now, isn't it? In math class, is x isolated? Do I like decimals? So this is done. Does this answer help us in physics class? No, because it doesn't tell us how fast something's going, right? You would not say that bullet fired out of that gun at the square root of 19 meters per second, would you? So it doesn't help us there. It also makes it very difficult to put on a graph, doesn't it? So now we're going to just estimate, because at the end of this unit we'll be answering real-life questions using quadratics. So what is about the square root of 19? It's a little bit more than 4, right? It's about halfway between 4 and 5, so but a little less. So 4.4 is cool. So this is either -4 plus 4.4 or what? Minus 4.4. So what are our values for x? 0.4 or 8.4. And if we were going to graph it, we'd have one guy way out here at -8.4 and one guy right there at 0.4. And it would look like that. Now remember, I'm not spending any real time on graphing now because it is very difficult to graph this stuff if you don't understand the algebra first. Yes. No. We would actually use our calculator. Right? But in math class, we're done here. Okay? But if it was a question like, how fast was the car going when it hit the wall? You wouldn't say, well, I'm going 4 plus, right? In this class, 9 times out of 10, you're going to leave it like that. Everybody cool? All right, let's turn the page over. What?
If you round it, it actually.
Oh, okay. This right here is going to show up all through this unit. It stands for Graphic Display Calculator. We are going to learn how to use, some of you already know, this calculator to make graphs. Like that. And you're going to learn how to read it. Some of you already know how, most of you probably don't. But we're not doing that till we have mastered the algebra. Okay? So I want to do this without the graphing calculator. So let's have a look at this first one. It's a nice easy one. X squared plus 14x plus 49 equals 5. What can you tell me about the left side of that equation? It's a perfect square, right? And we can do stuff with a perfect square. What would we do? We'd factor it to what? X plus 7 squared, and that would equal what? 5. What is our job anytime we see x equals something? Isolate x. What is in the way now? So I square root that side to get x plus 7. What does that equal? Plus or minus root 5. Now what do I do with the 7? I will bring it over and I will get negative 7 plus or minus root 5. Now you're smart kids. This is not important because this is done. But we are building towards graphing, yes? So I just want to mention the graphing. And here, Jacob, rather than get out our calculator, we're just going to estimate. What is the root of 5 approximately? Like 2.1? Are we happy with that? Because root of 4 is 2, right? So what are our possibilities for x if we needed a real life answer? Negative 7 plus 2.1 or negative 7 minus 2.1. Right? And I would have negative 4.9 and negative 9.1. So the graph would be over here. Is everyone cool? Everyone's cool? Okay. You guys try B. Go. What? No. Just for B, ladies and gentlemen, just get to here. Remember, all this stuff in black ink here, that's coming later. I just want to plant the seeds in your head. So when we get to the point where I say, do all this algebra and then graph it, you're all able to actually, oh yeah, okay, I know what he means. Anybody want the magic pen? Harmon? Yeah? Yeah.